doing the unsupervised part of machine learning. Let me share my screen and give me a quick yes if my screen is visible. If my screen is visible to all. Perfect. All right. Fine. Now, before getting started with unsupervised learning, so supervised learning you have already gone through. So supervised learning was all about training a model that is going to have a target value, right? If you are having X, then you have to predict Y. But here in unsupervised learning, the things are going to be different. Let's go to the next slide over here. What exactly unsupervised learning is? Now here, the data that we are going to use to train the model, or like there will be different things that we can do in unsupervised learning. So first of all, training the model. If we are going to train a model, here model is not going to get the target data, the target value or the target feature, what we want to predict. In supervised learning, few examples you might have seen, like you are creating a model that is going to predict the mail you are getting spam or not. You are predicting the person is eligible to get the loan or not. Or when it comes to regression, you are predicting the house price or car price based on the independent data. So we were having the concept of independent features and the dependent or the target features. Here we don't have target feature. Then what exactly unsupervised learning is going to do for us? So basically it is a type of machine learning model where the model is going to work without the labeled data. When I say labeled data means what? The data set that is having the Y column, that is the target column. Here we are not going to have. What exactly the model is going to do over here? The model is going to learn from the patterns. It will try to group the data that is having the similar data points, or the data point that is having some similarity. So it will try to find the hidden structure without any human intervention. Just one example, like you can see on the screen, here we have unlabeled data. So we have two animals over there. One squirrel, and sorry, three animals we have. We have a squirrel, we have fox, and we have owl. Right? Now we haven't given like which animal it is. We don't know which animal it is. Now here, what we are doing, we are giving this data to the model. Model is going to get trained and model will identify the difference between the data points, and it will create a group, and this particular group we can also call it as cluster. Cluster, you might have heard about this word cluster of stars. Stars means what? Group of stars. So based on the similarity we try to group the data. So here it is getting used, unsupervised learning mostly it is getting used for clustering task. And there is other aspect of unsupervised learning also, dimensionality reduction. What exactly it is, we'll discuss. We'll be having separate slide for that. And association rule learning. So association part you might have learned in school also, like it was there in maths book, a part of statistics chapter, where we try to find out if a person is going to buy bread, what are the chances they are going to buy butter or milk. So based on that, whatever we have learned in school, so the same thing we'll be putting over here in the form of code in machine learning. Fine. So here, moving ahead. So first of all, what we need to do in unsupervised learning, we collect the data, we train the data on the basically we train the model where we are not going to have the label data. We'll be selecting the algorithm. It could be any algorithm. It could be k-means. It could be dbScan. It depends what exactly we want to do. So once we are done with the model, the same technique that we have used in supervised learning, we are going to check the model. Check the model means what? We are going to test the model, how well our model is performing. Now metrics are going to be different over here. If you have done project on regression, if you have done project on classification, okay, can I come to know how many of you have done the project on regression and classification? Can you get some yes if you have done, or you can give me a thumbs up? Okay, so previously it was discussed, right? Now, when we are doing classification project or regression project, you're using some machine learning algorithm, and then we have some metrics. Metrics means what? Right. Metrics are going to be nothing but the measures that you are going to use to check the efficiency of the model, how well your model is working. Here also we will be having the metrics, but different metrics. In regression, you might have used mean squared error, mean absolute error, R squared, yes, root mean squared error. And when it comes to classification, you are talking about classification report. In classification report, we had precision, recall, F1 score, confusion matrix, all these things were there. Here we'll be talking about Silhouette score. Okay. Moving ahead. Okay, so the first thing that comes in unsupervised learning algorithm is going to be clustering algorithm. Now there are different types of algorithm, and each algorithm have different types of basically we will be having three types of concept. The first concept is clustering. Second is going to be hierarchy based clustering. Then we'll be having density based clustering. So clustering you will be having in three different types. So what exactly clustering is? Clustering means nothing but to group the data, to make the grouping of the data based on the similarity. Now here you can see in this picture, it's very simple to understand. We have three groups of data, right? Data point based on the value we have put it into different groups. The data point that are close to each other, that is making a group, we are giving a separate color. So basically this separate color is nothing but this is a cluster. And whenever a new data point will come on the graph, we are going to find out which is the nearest cluster, based on the centroid. We'll see. I'll do some drawing and I'll let you know how exactly these things work. So clustering basically help us to group the unlabeled data into cluster based on similarity. Goal is very simple. It will try to discover the pattern. It will try to establish a relationship between the data without having prior knowledge of the categories or the labels we have. Right? So basically it is going to group the data points that shares the similar features, characteristics. It will help us to find the natural grouping in the raw data or unclassified data. And it is commonly used for customer segmentation and anomaly detection, data organization, and where we are going to work purely on the input data without output label. There is no output label. Output label means what? Target data that we want to figure it out. Now the first algorithm that we'll be talking about is going to be k-means algorithm. Now here people will get confused between KNN and k-means. Okay, you might also get this type of question in interview. What is difference between KNN and k-means? So few of the things are going to be common. If you are going to look into the graph, or if you're going to talk about the concept, what exactly it is using. The one particular distance metric will be there called Euclidean distance. And I hope all of you have heard about Euclidean distance before. We have already seen this stuff in our school, right? In school, we have seen this thing, Euclidean distance. So what is the basic difference between KNN? So first of all, I want you to clear KNN. KNN, don't get confused with KNN. KNN is supervised learning algorithm, where we have Y column, that is the target column, that is dependent on the independent features of X. That means the same thing we can take about like this, if you are having a data set where you have different classes, that means you have something to predict. So that time you will be using KNN. But here K means we used to simply group the data based on their similarity. Now here in k-means we have k. K basically stands for the number of clusters you want to create. The number of clusters you want to create. A number of groups you want to create. Sometimes we also don't know how many groups can be created over here. For that, we can simply do a plot, and even in plot it is not clear. We'll go with a trial method. Trial method means what? We will be training the model again and again with different number of K. And we'll be talking about one method called elbow method to find out optimal number of K. Optimal number of K means what? Optimal number of clusters that can be created. Now, how does it work basically? It is going to initialize with selecting the K clusters. Let's say if I have taken 3 clusters, if I've given the value of clusters of K as 3. So 3 random centroid is going to be mentioned on the graph. The next step is going to be each data point is going to assign to the nearest centroid from the cluster. Centroid means what? Here it is going to be the centroid based cluster. Centroid based cluster means what? Here we will be having some centers. So centers with some coordinates. And it is going to be a iterative process. What exactly K-means is going to do? It will keep changing the clusters. It will keep changing the clusters, the centroid, to form it and to make it optimal. So to make it the optimal place where the clusters centers are going to be placed. So it is going to update and is going to repeat. So this type of things we are going to see. Let me explain this thing with one example. So we will be talking about clustering with an example. I'm just going to connect my tab so that I can draw and I can let you know what exactly it is going to be. And here I need your help. What type of help I need? We'll be talking about cars data. Okay, and we are also going to do one project on cars data. I hope basic understanding of cars you have, right? So let me simply open one sketchpad. I'm just taking a sketchpad and I'll try to draw a few things over there. Let's suppose we are having cars names. Okay, I'm taking some cars names over here. The cars names. Okay, now what are the cars I'm going to put? Let's say, for example, I'm going to start with Scorpio. I will take Tata Nano. Then I'll take Maruti Suzuki Swift Desire. Just a second. Desire. Then we'll be having, let's say, Thar. Honda City. Then, okay, few people are also giving some comment. Okay, you want me to put Jaguar, Bugatti and all. Okay, so Jaguar is a company. I'm taking the models, right? Scorpio is the model of Mahindra. I'm talking about the, not company, I'm talking about the car models. Okay. Then we will be having how many cars we have till now? 1, 2, this is Nano. 1, 2, 3, 4, 5. I'll take 4 more. So let's say Honda Verna. Then we have Bolero. I'm taking common cars that everyone knows. Common car names that everyone knows. So we have total 7 now. 2 more. Related to Nano, I will take, let's say, Maruti Suzuki Alto. I hope Alto everyone knows. Alto. And can you give any example related to Alto? Any car name? Related to Alto? Punch. Okay. Punch. So, Tata. Punch. Okay, as of now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have total 9 cars. Okay. Now here I need your help. What type of help? I need to create 3 buckets. I'm creating 3 buckets. Just a second. Tata Nano. And here I will be taking, let's say, yeah, I will be taking Honda City. And here I will be taking Scorpio. Okay, guys, now let me know. Alto I have already taken Nirmal. When you QA'd, okay, a lot of examples I am getting. I will fix it to 9 only. I won't take. Okay, give me 2 cards from the same list. Let's say we have a list over here. From this same list, give me 2 cards that is similar to Nano. Having some similarity. Some sort of similarity. Okay, Punch we have. Alto. Yes, exactly. So we have Maruti Suzuki Alto. Okay. And we have Tata Punch. Very good. Thanks for the help. Now, I want the similarities with this one. From the given list, Honda City. What are the cars similar to Honda City? Desire, yes. MS Desire. And we have Verna. Very good. Now, related to Scorpio, we have only 2 things left. That is, what are those cars related to Scorpio? Thar and Bolero. Now, here everyone is able to figure out what are the cars related to each other. Based on the similarity, we are able to separate, we are able to create groups, and these groups are nothing but based on the similarity, what we have created clusters. We have created clusters. These are the clusters. Cluster 1, cluster 2, cluster 3. Now, how you're able to differentiate between these clusters, how you are able to find out, okay, how these cars are similar. So basically, there are some cars category. Here I'm not talking about a sports car. A sports car comes within a different category. Here we are just taking simple cars over here. That is, okay, I got height and length. Okay, Aditya is giving the right answer. Okay, Parth is saying budget. Sonu is also giving right answer. Okay, whatever you are saying, it's true. CC, engine size, car type, very good. Duiz is saying car type. Sujal is giving the correct answer. Dasan also engine size. Okay, let me just talk about this one. Okay, so this type of cars that you have that are small in size, and they're having high mileage. Okay, now the thing is that over here, if you talk about 2 things, basically 2 things, I'm not talking about the price range. If you are going to take price range, you can take it. Price also is fine, but some type of, if you are going to consider price range, sometime what you will find, this type of cars. First of all, let me put the name of the cars. These categories. The first categories we call it as hatchback. Let me write it over here. Yes. Hatchback. The second category we have is sedan. And this type of cars are known as SUVs. Okay? SUVs. Micro cars, we call it as hatchback. Now, what basically the similarities these particular cars are having, that we have in hatchback, or the cars that we are having in sedan category, and the cars that we are having in Bolero. So 2 things are there that we have to consider. When it comes to sedan, if I'm going to talk about 2 things, the 2 things are going to be nothing but the horsepower and the mileage. Now, horsepower for the sedan is going to be, let me start with this one, not sedan. Let me start with, just a second. Let me start with hatchback first of all. Things will be more clear. Hatchback, the categories we have. Horsepower is going to be bit less as compared to other cars, but mileage is going to be more in hatchback. Then what we have sedan, right? Let me also put this thing, SUVs. Horsepower is going to be less, mileage is going to be high. When it comes to SUVs, horsepower is going to be as compared to sedan and SUV, it is going to be moderate. And mileage is also going to be moderate in sedan. But when it comes to SUVs, horsepower is going to be high, but mileage is going to be less. Right? These are the similarity. If you talk about the details of the car, this thing also comes in between. What horsepower, what is the mileage? Mileage means what, how many liters of petrol it is consuming, like how many kilometer it is giving in 1 liter of petrol or diesel, or you can also take miles per gallon, how many miles per gallon you are able to travel with that particular car. Now there could be more features, but these are the two very common features that you will find over here in all these particular types of cars. Size is there, shape is there. Based on the shape, we are saying this is sedan, this is SUV, this is hatchback, the size and all, it's all there. But let's say you are getting some car, you are getting a new car. On what basis you are going to classify? Okay, shape and size is there, but shape and size will not always documented in the data set. What will be having horsepower always. Whatever the car you're going to buy, you can ask for the horsepower, you can ask for the mileage. These two are the very common things. And we'll be doing one project. I will be sharing the notebook with you and the data set as that I will be using. Okay, Aditya is asking cost. Okay, now Aditya, just imagine over there. Sometime few of the sedans that you will be getting, the sedans, if I'm going to talk about, sedans are going to be expensive than SUVs. Sometimes SUV is more expensive than sedan or hatchback. So cost we can't take as the parameter over here. If I'm taking cost as the parameter, so that is going to be different classes of the car. Okay, based on the cost. We will be talking about the class, S class, and different classes, right? So we'll be talking about premium cars. In sedan also we have premium cars. In SUVs also we have premium cars. Premium cars, let's say like you have BMW and all in sedan. You have also SUVs like G-Wagon and all. So prices is going to be more over here, but hatchback price is going to be less always. Yes, very good point added by Vivek over here. Cylinders. Yes, number of cylinders also is going to be one of the parameter. All right. I hope you are clear about clustering over here. What exactly the concept of clustering is, why it is needed. Now let's try to understand how basically K-means clustering is working, right? We are talking about this particular algorithm right now. K-means clustering. K-means clustering. Now, let's say I'm having this particular data with me. I'm only having this particular data with me, where I have the what I have, let's say, two things: horsepower and mileage. Let's say we have horsepower and we have mileage. Okay. Now, let's say I'm giving some colors to the cars. Let's say red color represents hatchback. Now hatchback is going to have less. Let's suppose your graph starts from 0. Always it will start from 0 to some value. Okay. Some sort of values will be having 1, 2, 3, something like that, or 10, 20, 30, something like that. Let me take only 1, 2, and all. 1, 2, 3, and so on. And you are having also here some values. So on. We have horsepower, we have mileage. If I'm going to consider the cars related to the category hatchback, horsepower is going to be less, but they will be high in mileage. So you could find those type of car details over here when you are going to just do a scatter plot of these two columns. You will find those type of car details over here. Then comes to next category. The next category that we have sedan. As I told you, sedan is going to have moderate horsepower and moderate mileage. Mileage is also not going to be that much good. So horsepower is going to be more over here. But the mileage is going to be less. Right? Then we have finally sedans. Sorry, we have this SUVs. In SUV, we will be observing very high horsepower. Horsepower is going to be more over here in SUVs. Sometime more, very high. But mileage is going to be less. Now, what you can see over here, just a second. Yeah, what you can see over here, you are having different groups over here. If I'm not going to give the colors also, you will be able to find the groups. If I'm going to remove some data points over here, let's say I'm just erasing this part from here, or if I'm erasing few parts from here, easily you can find out the groups based on the given features, right? How k-means is going to work over here. Now, let's say we are giving the value of k as 3. Just for the consideration, we know like only 3 classes will be created. Sometimes we don't know how many classes are going to be created over here. We are assuming only 3 class is fine. Not more than 3 we need it. So what will happen? K-means is going to initialize a random. Let me change the color. This color would be fine, green. So it is going to take one data point randomly. Sorry, if we are taking 3, that means 3 data points randomly it will be taken and it will be considered as cluster center. Now what it will do, it will try to calculate the distance between all the clusters. And based on the distance, what it will try to do, it will try to assign all the data points in the clusters, and if the distance are not that much uniform, so it is going to also shift the clusters. So from this, the cluster center can shift to this. From this, the cluster centers can shift to this. So it is going to shift the cluster center until and unless it is not getting an optimal place where the distance between all the data points are uniform, or you can say normally distributed. Okay, so finally it is going to just keep the data points in the same way, and it is going to find out the optimal cluster centers. And this is the iterative process. This is the iterative process. Let's say this is the optimal cluster centers, and let's say we are having the optimal cluster centers over here. Okay, where the distance between the classes, the data points are uniform. Now, once this thing is done, let me just change the color again. Once this thing is done, what will happen? It is going to form its own cluster now. It is going to form its own cluster. Now, here I am creating a boundary, but this boundary is not there. Okay, just for an assumption, we are creating this particular boundary. These are the different clusters we have. Now let's suppose a new data point came from nowhere. A new data point came from nowhere, and that data point, let's say, just a second, that data point is going to be of this color. Let's say this is the new data point, or let's say here we have got the new data point. Now, how we'll come to know which particular clusters this particular data point belongs to? Now, what will happen if a new data point is coming? So here what we have the coordinates, right? We have the coordinates. If this data point is coming, this data point is having its coordinate. So let's say you have x-axis and you have y-axis. So it is going to have it is going to have x1 and y1, right? And here this cluster is also going to have some coordinate, let's say x2 and y2. This cluster is also going to have some coordinate, let's say x3 and y3. Now it is going to calculate the distance. It is going to calculate the distance between all the clusters. Now whichever is the nearest cluster means what? Whichever is the nearest to it. Let's suppose the distance between this data point and this cluster centers is the nearest. It is the shortest distance. Then this particular cluster is going to be, this particular data point is going to be considered as the data point of this particular cluster. Let me give a name, A, B, and C. So cluster A, it will get assigned. Now if we talk about this one, it is going to, again, the distance will be get calculated from this all the three cluster centers. Whichever the nearest cluster centers are there, this new data point will get assigned to that cluster. Let's say it is the nearest cluster we have find out is C. So this new data point is going to be assigned to this cluster C. Now one question is there. Your cursor cannot show. Okay, my cursor, you're not able to see my cursor. Guys, can you see this cursor? I'm moving my pointer over here. Can you see this cursor? Yes, right? Okay, Chirag, you might be having some network problem from your end. Check your network, okay? It's visible for everyone, you can see. Fine, thanks for the update, guys. Thanks for the confirmation. Now the question is, how it is calculating the distance? What is the distance matrix getting used? The distance metric that we are using over here, we call it as Euclidean distance. Just a second. Euclidean distance. Okay. Can anyone tell me what is the formula of Euclidean distance, if anyone remembers? Formula of Euclidean distance. Anyone? This is coming from your school notebook, right? You can write in short also. I'll understand. Yeah, it is hard to put over here in the chat, no problem. So Euclidean distance is nothing but under root of the coordinates. Okay, very good, very good. I'm getting the correct results over here. Yes. So it is going to be x2 minus x1, x2 minus x1 plus y2 minus y1. And here we are taking the square of this distances. x2 minus x1 ka whole square plus y2 minus, it is minus y1 ka whole square. I hope all of you have used this particular metric in your school time. We are talking about the mathematics from the school level, high school level only. We are not talking about any graduation mathematics. Simple mathematics are getting used over there. So this is how K-means is calculating the distance from the new data point to the given data points, given cluster centers. And cluster centers were also assigned with the same. So it was calculating the distance, and wherever it got the uniform distribution of the distance, that particular cluster centers had been taken. And how it was calculating distance? With the same Euclidean formula. Okay, Euclidean distance formula. Fine. I hope everyone is clear about it. We'll be talking about more on maths. Okay. Machine learning is all about maths and stats. Okay, you can't run behind maths and stats. So the first clustering algorithm we have, we'll do one project. Let me discuss few more things over here. We have one more type of clustering algorithm, but this type of clustering algorithm, it is not getting used in market. Okay, truly I'm saying it is not getting used in the market. Okay, sir, how initially set centroid in the group? So basically, Krishna, let me just take you back. Nice question you have asked. Now let's say two centroids are taken over here. This is the first centroid, this is the second centroid. Now we can see the distance between two centroids are very near. So it will shift the centroid from here to somewhere else. It will keep one centroid and it will keep it somewhere else. Right? So three centroids we have to create, and randomly any data point can be considered as a centroid, any random data points. And again it will start calculating the equivalent distance between all the data points in the given clusters. So cluster is not created initially. So the centroid that we are giving, or that the model is taking on its own, it is going to calculate the distance between all the data points that are close to it. And it will keep shifting the centroid from one data point to another data point based on the distance that it is calculating. And until and unless it is getting an optimal place, let's say this particular place, where the distance between all the data points are uniform or normally distributed, then only it is going to stop. Otherwise it is going to keep iterating. It will keep changing the centroid. So here we have the same thing over here in this. Okay, can you see over here in this particular animation? So this star basically represents the centroid. The stars that we have over here, it basically represents the centroid. Now you can see the centroids are shifting from here and there until unless it is reaching a position where the distance between all the data points of its own cluster is uniform. This is how the model is going to create a cluster. Making sense now, Krishna? Perfect. Guys, keep asking questions like this, okay? I enjoy when you are asking questions. Otherwise, it is going to be a one-way communication if I'm only speaking and all. So the same thing you can see over here also, like how the cluster centers are getting shifted. Now, according to this particular picture, we have 5 cluster centers. You can have n number of clusters. It totally depends what type of data you're having, how many classes you want, or how many groups you want in the data. So basically we are creating classes only. We have unlabeled data, we can make the data labeled. Fine. The second type of clustering we call it hierarchical clustering. So K-means is centroid based clustering. Centroid based means what? It is initializing a cluster center and it is going to perform the calculation. Here we have hierarchical. Hierarchical basically it works on the hierarchy, how it is going to create the clusters and all. So it totally depends on, you can see there is a type of graph, we call this graph as dendrogram. So basically it is going to be a bottom to top approach. Bottom to top approach means what? So at the bottom of the dendrogram, so you can see there are different points, point 0, 1, 2, 3 and all. So First of all, it will be all separated over here. As we move up, the closest points are going to merge to form a single group. So here P5 and P6 are creating one group. Now if we go more above, we are going to find P4 and this particular group working together. Then we'll go more above, and here we will be finding another groups. So how basically the clusters are going to be created? So it will work on this particular level. So where you have a particular graph and it is not having any hierarchy equal to each other, that is going to be considered as a separate cluster. So the lines connecting the point to show how they are progressively merged based on the similarity. So basically, dendrogram works on the height, the height at which they are connected to show how similar points are to each other. And basically, it is not getting used in the industry because this type of algorithms are not that much optimal to get the. Okay, a very nice question asked by two people, one by one. Not three questions I have. I will be asking. I will be answering the questions one by one. So first question is from Vivek. Sir, what if there are too many data points and for each and every data point the centroids kept shifting? Yes, sir. So we don't need to worry about that. Too many data points. Let's say you are having millions of records. So millions of data points you have. It totally depends how many clusters you want to create. If I want to create 5 clusters, only 5 clusters will be created. And this headache we don't need to keep if too many data points are there. All the things are going to be managed by the algorithm itself, the model that you're going to create. Model is going to learn on its own. We are not going to teach the model. We will be asking the model, take this data set and learn from this data set. Try to find out the clusters. Try to create the group. And it is not going to shift from each and every data point. Even if it is going to each and every data point, we don't need to worry about it. Yeah, it will take some time. If you are having millions of record, it will be time taken. Yes, time will be taken. It totally depends. If you are working on a clustering algorithm, here we are talking about, if I'm talking about this thing, right? It is a centroid based clustering. That is this one. Let me just go back. Let me go back to the previous slide. Where is my yeah. Yes. So here, time totally depends on two major factor. What is the size of your data set? What is the size of your data set and how many clusters you? Okay. And the major factor is going to be nothing but the size only. It's going to be size only. What is the size of the data set? Yes, if your size of the data set is more, it's very simple, guys. If I'm going to give you one page to learn in 5 minutes, or let's say if I'm going to give you one page of essay and I'm asking you to learn it, you may take 5 minutes. Now, if I'm going to give you 3 pages, you will take more time to learn. The same is for model as well. Yes, exactly, Chidar. Moving ahead, how cluster face similarity, how cluster know that features. Very good. How cluster know that features. So basically, we are giving the selected features only. We are not giving the entire data set. Look, at the end, we are solving the business problem, right? And we should know about that particular business, what that business is all about. Let's say I'm solving the problem of car data, like car business. Now here I should know how basically this business works, what are the details. Now we all know about the cars, that's why I'm taking the cars example. You know about what is mileage, you know about what is horsepower, right? These two are very common in all the cars. Now here we have to find out what are the features are going to affect the learning most. Now, if I'm going to talk about customer data, let's suppose you have to divide the customers into different buckets, different clusters. We are not talking about customer name, email ID, phone number, and all. You tell me, if I have to do the customer segmentation, what are the customer details I need? Can you give me some examples over here in the chat? Anyone? If you are having customer data, then how you will work? What are the features you are going to select from the customer data? Okay, male, female, that is gender. Very good, Manas. Apart from male and female, what he buy? Customer ID, no, customer ID is not going to be, customer ID is their own thing, right? Type of products they are looking for, department they work, okay. Salary, okay. Now, the thing is that salary of the customer we can't ask. We can't ask the salary of the customer. Age, exactly, that's age. Now, let's take gender and age. If you have these two only, there could be more factors also. How much amount they are spending, how often they visit the store. There could be a thing. But no, this type of data is not useful to train the model, like name of the customer, phone number of the customer, or the customer ID, because model can't do anything with that. If I'm going to teach with the model, if the customer ID, this customer will buy this product, no. We are going to simply give the details that is required. So name and gender is going to be the perfect parameter over here. Now, let me ask you about the recommendation of the product you get online. Let's say if you are an 18-year-old boy, what type of products you will get recommended online? What type of products? And all this platform, they know about what is your age, what is your gender, right? Based on your search and all. Yes, mobile phones, laptop, some gaming consoles and all. Now, let's say you are an 18-year-old girl. What type of products you will get in recommendations? Yes, courses also there. Courses is common for all boys and girls. Okay, clothes, mostly clothes. Girls are more into clothes, makeup. Okay, fine. Now let's shift the age. Let's say you are a male and you're 40-year-old. What type of products you will see in recommendations? 40-year-old male. Okay, grocery. Grocery will come. Fine. Apart from that, yes, perfume, medicines. Okay, nice example. Aditya. Car, bike, houses, exactly. Now let's shift from male to female. A 40-year-old female, or let's say 30-year-old female. What type of recommendations they will get? Makeup will be sure, okay, makeup kits. Apart from that, baby products, like this is the answer I was looking for. Jewelry, yes, jewelry will be there. Jewelry is for all the age group. But baby, okay, one good answer I have got from AnujSadi.com. Okay, let's say you sell baby product. You are the owner of the baby product, and you are showing the ads on YouTube, Instagram, everywhere. What are the age group and what are the gender you will target? Always you will target females, and females of a particular age. Let's say 25 to 35. So this is the particular age. Yes, till 40 also we can go. So this is the particular age, let's say 25 to 40 or 25 to 35, where female are likely to be a mom or mom to be. Now, if I'm going to show them the ads related to or the products related to baby use a baby product, anything. So I will be having more chances to increase my business. Now I hope you understand why features matters. Features means what? The details matters. Based on what you are going to do the segment. If I am doing the customer segmentation, I can recommend the product, right? Similar product to those customers, right? Weight reducing products, exactly. Weight reducing product. Even I am getting this type of ads, weight reducing products. Gym products, very good. One more question was there. I'm not going to leave any question in the chat. Look, the chat become clusters. So, one very good question was asked by Pujan over here. Sir, how practically we can develop these algorithms? Okay, as of now, what we are doing, algorithms are already created. We are just importing it. We are using it. We are not developing the algorithm. The question asked by Pujan is how we can develop this algorithm. Now, to answer this question, I'll give you one context. The need of algorithm is totally based on the demand of the market or the business, right? Now, if you want to develop the algorithm, first of all, you have to clear the concept of data structure. First of all, you need the very deep knowledge of data structure. As of now, we are just importing and then using it. And not only the data structure, you should also have the very good knowledge of maths and stats. If I'm going to talk about this thing, let's say there is an algorithm called Naive Bayes, classification algorithm Naive Bayes. Naive Bayes is totally based on Bayes theorem. Now, if I don't know what is Bayes theorem, I won't be able to develop this type of algorithm. It is already developed, and the best thing about Python is it is open source. You can develop your own algorithm and you can publish it. Yeah, you can do all these things. You can create your own library, you can publish it. Now, developing algorithms basically requires the knowledge of maths and stats and knowledge of data structure, how you are going to train the model, how the model will get trained. So it basically needs the understanding over there, and then understanding how data you are going to manage with a particular model. So every model is hard coded. We are importing and we are using it. Someone has written the code for that model. It is not like that model come from the sky and we have downloaded it. No, everything was hard coded. Sometime you can develop your own algorithm, but again, what you have to do here, we do the coding in in the way of OOPS. So we will be creating a class. If I am importing a model, okay, what was the last algorithm you have studied in supervised learning? I will take that example. I'll explain you. What was the last algorithm you had? Anyone in machine learning? Before this, I think you were having linear regression and decision tree. Perfect. Let me take a very simple example here, linear regression. Now, linear regression, you're importing the class. You're creating the object of linear regression. And that object have many methods. Okay. If I'm going to talk about, by taking the example of OOPS concept, linear regression is the class. If you're creating one new algorithm, you're going to create one class, my algorithm, or whatever the algorithm you are going to give. You have created the class and you will be defining the methods. The methods are going to be the functionalities. Okay. How basically your model is going to get trained, you have to put over there, and what actually maths or stats you are going to use, you have to implement it over there. So you will be creating the class, you will be defining the methods over there, and that's it. But it seems it is easy, but it's not that much easy, because it needs very deep knowledge of understanding of maths and stats. You can start learning about all this thing. I'll tell you one thing. I hope all of you have heard about Copilot, right? Copilot everyone knows. I'm just taking example of Copilot. I have it over here. I will be using this thing. Let me have it here in the chat. I have Copilot added in my, this browser. I will be asking one question. So there is a concept of neural network in deep learning. So write a program to create neural network from the scratch. Scratch means what? From the starting. Scratch spelling is wrong, I guess. Yes. So you will get, I think it is going to create a class first of all. Crafting neural networks. All right. Coding without a string. Taking step-by-step decisions over here. Okay, I have asked to create the program. Okay, we will be getting the full program over here. Okay, so the whole code we have got. Now, if you are going to look into the code, guys, here it is creating the function, right? These are the different functionalities. Now, here you can see the concept of options coming up over here. The class layer. In neural network, we add layers of neurons. So this is how you can learn how to create your own algorithm. Okay, so you can see some maths are also involved over here. Math.sqrt, we are taking the square root, we are taking the help of randoms, right? You have the concept of gradient descent, right? So this is how you can learn. So for optimizers also, it is writing the code from the scratch. I hope I answered your question. I forget the name. Yes, Pujan. How basically you are going to write the algorithm from the scratch. You can write the algorithm from the scratch, create your own library, publish it. You can publish your own library. Let's suppose I can create a library with the name Pujan and I can simply publish it. Once I publish it, so people need to install, people installed Pujan. So you can do it like that. Okay, just give me a second. Okay, sorry about that. Okay, perfect. I hope it is clear for everyone, not only for Pujan. I'm not only explaining this thing to Pujan. If you're asking something, yes, it is for everyone. The answer is for everyone. Perfect. Now it's good to look into all these things. If you are planning to create your own algorithm, it is going to add what we call it cherry on the cake on your resume. You can mention this thing, and you can write a research paper. Write a research paper, publish that research paper. And research papers, they matter a lot on a resume if you're having research paper. Nice findings we have got. All right, let me discuss few more algorithms over here, then we will come back to the next one. Clustering we have seen, hierarchical we have discussed. So it basically works on the hierarchy, how many data points are close to each other. So based on that, it will be creating clusters like this. Now, but the thing is that hierarchical clustering is not that much optimized. It is not giving that much good result in clustering. That's why it is not getting used in industry. I haven't seen anyone using hierarchical clustering. You will find people using K-means. You will find people using this algorithm called DBScan. DBScan is also one of the powerful algorithm, and DBScan stands for density based. Uh, Let me just show you this particular file. I have a file for you, and I will be sharing that particular file with you. So this file I will be sharing, and one more file I have for DBScan practice as well. I will be sharing that file. All right. So this documented file I will be sharing with you, but you need to download it or you have to save it as a copy, because I'm not going to share with the editor access. I will be sharing with you with viewer access. So basically DBScan stands for density-based spatial clustering of application with noise. And this algorithm, guys, was developed long ago. How many years ago? 30 years ago, in 1996. Now, this algorithm comes from statistics. Okay, so a statistician, the scientists who were there, who they created this particular algorithm, and prior this, it was not getting used through programming. But as a computer scientist, or let's say you are a computer science student, you can take a particular algorithm and you can write code for that, and you can create your own library. So, like Poojan has raised one question: how we can create one algorithm? So this is how you can create an algorithm. So all the algorithms are coming from maths and stats that it's there in the books. Okay, you have to just study that thing. You have to get the knowledge. You have to be, perfect in that particular algorithm. All the algorithms are coming from statistics or mathematics books only. Fine. So DBScan basically it's a density-based clustering algorithm. Density-based. So the name also it says density-based clustering, density-based spatial clustering, and noise application with noise. Now noise, what exactly noise is? Now if you are going to see this particular dot over here, that is not becoming any part of the cluster, that is going to be considered as noise. And DBScan comes with two basic parameters: epsilon, E for epsilon, and mean points. So basically, it is going to identify the core points. Core points are going to be any point that is there in a particular density, where we are able to create density. And mean point represents minimum point in that particular, in a particular given epsilon distance to the circle. Okay. Let's come over here, then the things will get more clear. Now let's say this is the core point. This is the core point. From this core point, we are going to create a radius of epsilon distance. And from this epsilon distance, we will try to find out, are we getting minimum 4 data points, 4 points? If it is there, then it will get considered as one density. Then it will move to other points. There could be other points also. And the point that is coming over there and it is not forming any other, let's say here we have created one circle, and from the other point we are not able to take any other circle, that particular circle is going to be considered as border point. And the data point that is not part of any clusters, those who are going to consider as noise. So noise are the data point that we don't need to consider. We can simply remove it, and that is not going to be the part of the cluster. The file that I will be sharing with you here, I have added one more thing over here. Now you can understand the difference over here between DBScan and K-means. K-means is fine when you are having the data set like this. Like this means what? Which are closely packed. Closely packed. When you are having closely packed data set. But DBScan is not going to work. So DBScan comes with advantage, also disadvantage. K-means will work well when you are having this type of, let me just close it. When you're having this type of formation of the data, when your data points are closely packed. But when you are having this type of formation, where this is a different cluster, this is a different cluster. So basically these clusters that we are able to make, it is based on the density, wherever the data points are dense. Now between these two, you can see the distance. So that's why this orange points has been taken as other clusters. But when it comes to K-means, as K-means is the centroid-based clustering algorithm, one cluster center will get created, and based on that cluster center, you will be having the clusters created. So when you have the clear separation between the data point, and data points are the what we get, the clusters are dense, that time you can go with DBScan. DBScan, one of the most powerful clustering algorithm that you can blindly trust. So here this type of structure we call it as moons. Okay, so in moons also you can see you are able to create separate clusters over here, but here we are not able to find the good clusters because few data points from these clusters are taken as the cluster of this blue class. Here also you can see some mismatch happening. This particular part is considered as different cluster in K-means, but here it is taken as the same. DBScan and K-means will work well when you are having this type of separations. Okay, and one more thing about DBScan, in DBScan you don't need to mention what type of, like how many clusters you want. In K-means we have to tell, I need 3 clusters, I need 5 clusters. But in DBScan you don't need to mention how many clusters you want. It is going to create the cluster based on the density. For example, I have added one more picture over here, so you can understand from here, and look at this particular animation, a GIF file. So here clusters are getting created based on the density. How many clusters will get created? 1, 2, then we'll be having this I, 3, and here 4. I hope difference is clear, right? 4 clusters, yes, right. Okay, previous session. Okay, I'll ask Aman sir. Okay, Chirag. Supervised based or unsupervised? Okay. Thanks for asking this question. Chirag is asking, is supervised based or unsupervised? We can't compare. Okay. Here there is no need of comparison because supervised are different category of machine learning, unsupervised is different category of machine learning. We have to find out what problem we are in, right? What problem we are facing. If you are using a data set, where it is clear that you need to predict something based on given X, you have to predict Y. Based on the given house data, you have to predict the price of the house. Based on the car data, you have to predict the price of the car. Based on the emails, you have to predict the email is spam or not. That is supervised. But in unsupervised, what we are having, we are not having that particular Y column. Both are used for different purposes. Exactly, Nirmal. Both are used for different purposes. Fine, I hope it is clear. But guys, keep asking this type of questions. Don't worry that that particular core topic was discussed, long ago and all. You can ask. You can ask the question from the previous session also. No problem. I'll keep the chat window open. Let's come back over here. I hope DBScan is also clear. Can I get a quick thumbs up from everyone? Is DBScan is clear? Is K-means is clear? Can we go to the hands-on part now? Perfect. Okay. Fine. So guys, for the time being, I'm going to use Collab. We'll come back to DVScan file later on. First of all, I'm going to share this link with you here in the chat. Let me take everyone over here, and I am going to share the viewer access. Okay, I'm giving you the viewer access. So this is the file. Sorry, this is the Collab link. I have shared the Collab link. I'm also sharing the dataset with you. Dataset I have in Drive. I will be sharing the Drive access, guys. Okay, let me open the Drive first of all. Just a second. Let me just have a look. What was the file name? Just a second. Till then, what you can do, you can click on the link. You will land on this page. You can click on file, and what you can do two things. Either you can download the notebook, or you can save a copy in Drive. The best way is going to be saving the copy in the Drive. Let me connect the Drive. Okay, the same name I have, Auto MPG CSV. Auto, sorry, Auto MPG CSV file. Here it is. I'm sharing this file with you. You can download this file. You can keep it with you. For this file also, I'm giving you viewer access. Why viewer access? Because I don't want anyone to change anything in the file, because I'm using this file again and again. So this is the dataset, guys, that we are using over here. I have given you both things, the notebook and the dataset. Let's get started with the practical part. All right. So I already have this file in my Drive. So as you have seen in my Drive. So in my Drive, I have this file. I have just copied the, excuse me, I have copied the path of this file, and I have this file. I have copied the path and I have pasted it over here. Now we are going to run the things from the scratch. I'm going to restart that session, and I'm going to clear the output. Let me clear the output, clear all outputs. I'm going to start from the scratch. Here I'm importing all the important libraries that we need: NumPy, Pandas, Seaborn, and Matplotlib for doing some visualizations. And we are loading our dataset. So dataset got loaded in data frame df. We got the data frame. What data we have? We have MPG, we have number of cylinders, we have displacement, horsepower, weight, acceleration, model year, origin, and the car name. We don't have anything over here to take it as prediction column. So what exactly we are going to do, as I have shown you, like when I was discussing about the cars. So I have taken two things that time. That was horsepower, right? Horsepower and mileage. So here the mileage is given in miles per gallon. MPG means miles per gallon, right? So we will look into the info, what info we have. And as we know, whenever we are giving the data to the model, that data should be in the form of numbers, either int or float. Int or float. Here we need to do some data processing also in this particular file. Moving ahead. So the columns that we need, MPG and horsepower, both should be in what? Both should be in the form of numbers. So MPG is in float. But the horsepower that we can see, it is considered object. Why it is considered an object? Let's see. We can find the unique. Now, when we look into this data set, what we have find out in this column, each and every data point is getting considered as a string because it is wrapped inside the quotation. Now, with only a single value, the data type of the whole column will get affected. Why it is so? Here, if you're going to see, there is a question mark over here. Question mark is also a type of value over here. Now, question mark over here, we can consider it is a null value, although it is not null, but as of now, we'll be considering it is null value. Now we need to replace this null value and we need to convert this particular feature into number, either float or integer. Now we need to replace this null value, right? And what is the size of the data? We are using very small data set right now, that is 398 rows and 9 columns. Out of 9 columns, we need only 2 columns for our use. We are going to filter out the data where horsepower is not equal to question mark. So first of all, we will be taking those data. So out of 398, 392 rows are not having question mark in the horsepower column. But still it is not considered as numbers, a float type column. What we are going to do, first of all, we are going to convert it into in float. So x dot horsepower. So we have created a new data frame x. You can give it any name. As type float. So this horsepower will get converted into float, and we are going to see the distribution. Okay, can anyone tell me why we need to see the distribution before replacing the null value? Anyone? Or filling the null value? Why we need to see the distribution? Any idea? Anyone? Check if null values are small or large. Okay. Okay. Any other thing you want to add? To test. Okay. To test. So it's not replaced by any highly deviated variable. Very good. To check the distance from median. Very good. To understand the data also. Okay, Nirmal is saying to check the distance from median. Makes some sense. To understand the data by Vivek. Aditya is saying it is not replaced by any highly deviated. Sorry, a lot of chats I'm getting, so not able to read deviated variable. Do is just saying check the difference. We shouldn't get high variance. All right. I'm getting almost right answers from everyone. Now, according to the concept that we discuss in data science or in AI, if you are having a numerical column, either is an int or float. Now, if you are having numerical column that is having continuous data, I'm talking about continuous data. Horsepower is a type of continuous column. It could be anything. Now, if it is having null values, we are going to replace the null values either with mean or median. Mean or median. Now, when we are going to replace it with mean, when you are having normal distribution, to see the distribution, we are plotting this histogram. So if you want to see the histogram, you can also plot with SNS, this plot, distribution plot you will get. Now let me tell you, let me take back you to this drawing tool. Just a second, it's my pen. Yes. If we talk about guys distributions, there are different types of distribution. I'm not going to include all, but basically, what we have, let's suppose you have a graph and you are having the distribution like this. So when you're going to have bell-shaped distribution, we call it as normal distribution or Gaussian distribution. In normal distribution, the mean and median that you will have, it will be at the same place, like here, or near to each other. So mean and median will be near. But we have skewed data also. Skewed data means what? Skewed distribution. Just a second, let me just remove this thing. I'll create it again. When we have either this type of distribution or we are having, just a second, let me change the color. Yeah. Or when we are having this type of distribution. So this type of distribution, we call it as skewed. These two are skewed. These two are skewed. When it is skewed, the thing is that over here, if it is this type of skewed, or we call it as left skewed and we call it as right skewed. In left skewed, mean is going to be higher. Mean is going to be higher. Mean will be here. And median will be here somewhere. Like it could be anywhere. Median will be less. Mean will be higher. And when it comes to right skewed, here median will be higher. Let's say, and median will come over here. Now, what exactly we have to do when you're having skewed data, either you're having right skewed or left skewed, you have to go with median. You have to go with median. When it is right skewed, you have to, sorry, when you have normal distribution, you can simply go with mean. Mean or median both are fine because it is going to be equal. But here, the mean will be less over here when you are having right skewed, and median will be more. And in left skewed, mean will be higher. This is the mean, and this is the median. Mean will be low. So this is the main difference. And whenever you are having this two type of distribution, we can go with median. You can go with median. When you're having this type of distribution, you can go with mean. That means to replace the null value. So as of now, what type of distribution we have? Do we have normal distribution or do we have a skewed distribution? What do you say? Everyone. What's your call here? What type of distribution we have? Okay, course is saying skewed, left is skewed. Okay, right is skewed. Okay, I'm getting right answers over here. So basically this is right skewed, guys. This is right skewed. Yes, right skewed. This is right skewed data. Sorry, the data that we are having right now, this is not right skewed. This is left skewed. Sorry, this is left skewed. You are having this thing left side. So this is left skewed. Sorry for that thing. Now we have skewed data, right? What we have to do, we can't go with mean. So we will try to find out what is the median value. So here we are going to take the median of this particular column. We got what? 93.5. Now what we'll do in the original column that we have in our data frame, we'll take data frame horsepower, we'll do replace. What to replace? To replace question mark with what value? 93.5 and in place equal to true. Because we want the changes in place. So we'll run this and here we'll be getting this thing. Fine. Now we are going to do this thing, that is we will be converting this data type of this particular column into float and it will get assigned. Now we got the perfect column. Okay, so let me clear this thing. People are getting confused between right is skewed and left is skewed. Right is skewed and left is skewed. So here I have clearly mentioned, look, simple, it is very simple. It is about the gap. If you are having gap left side, this is left skewed. If you are having gap right side, this is right skewed. The distribution that we have right now over here, yes, it is right skewed. Yes, you are right, though it is right skewed. Sorry, like I also got confused between right, left. I got so many right, left in the chat. Skewed, it is not skewed. Skewed, skewed. Okay, not squid again. Okay, that not squid. This is right squid. Let's come back now, guys. What we have done, we have made our data set ready. All right. What we need to do, we need to create the model over here. This one, yes, this one is right skewed because you are having gap right side. Okay, this is right skewed. If you're having more gap right side, that means it is about the gap. Which side you are having the gap. If the gap is on the right side, it is right skewed. If the gap is on the left side, it is left skewed. All right, let's focus over here. Now here comes our algorithm. We will be creating the model. From scikit-learn library, we have one module called cluster. In cluster, we have this class k-means. We are going to create k-means with n cluster. N cluster stands for number of clusters. Now, if you want to explore more about k-means, what are the different values you have, so you can simply mention on Google k-means. Okay, scikit-learn k-means. Better to go with the official documentation, and here you will find. Look, by default it is 8. By default it is 8, and these are the different parameters over here. We are going to change. Not always 8 is required. Okay. Whatever problem, 3 is fine. Sometimes 4 is fine. Sometimes 5 is fine. So as of now, we'll be creating the model with n clusters 3. All right. What columns we have? We have these columns, and as of now, we'll be taking MPG, that is miles per gallon, and we'll be taking horsepower. Let's run this. Here we go. We are taking miles per gallon, that is mileage, and horsepower. What we have done, we have taken only 2 features over here. Okay. As of now, what I think, only 2 features are fine. So based on these 2 features, I will try to create clusters. Now we will ask the model to fit into this DF. Now, what you have done in supervised learning, you have taken X and Y, if you remember. Here we are only taking X, not Y. Y is not there. Only X parameter is required. So here we are going to run this, and here we go. Our model got trained. Okay, it got fitted. Fine. Now, once the model is trained, that means, okay, how the model got trained so fast, because you have only very less amount of use. Okay. In the meantime, you will be working on a very large amount of data. So here we are taking model, the model that has been trained with fit. It got fitted on this data set. We can ask for the cluster centers. Now, what it will give you, how many clusters we have asked the model to make? 3, right? So we will be getting the array of 3 clusters. Here you go. What we have got? Array of 3 clusters, and these are the coordinates. x1, y1, x2, y2, x3, y3. Okay. And what are the labels predicted by the model? Labels means what? If cluster 1 is created, so we know the counting starts from 0. So if we have made 3 clusters, so it is going to give the label 0, 1, 2. So that's the same clusters you will be getting over here. Now, what is the distribution over here? How many zeros, how many ones, how many twos our model has predicted or taken over here? So I'm using the count plot over here. So what we can see, the highest number is of 0, then 1, then 2. Let's try to plot all these things over here. What we are going to do, we are going to plot on the basis of these labels. We are going to do a scatter plot of these 2 columns, that is mileage. We are taking the value of mileage column, and we are taking the value of horsepower column. And here we are giving what? C, that is color. Color will be based on the labels. What labels we have? 0, 1, and 2. For all the data points that represent 0, that will be in different color. 1 will be in different color, and 2 will be in different color. And C map, that is color map, as of now I have given them. Any color it can take. So here we go. Now what you can see, we are able to see there are different classes over here, different clusters. But where are the cluster centers? Are the cluster centers placed at very specific place? Let's see. So here what we are doing, we are creating the array of cluster centers, and we are going to plot it based on the rows and column. Okay. We have plotted it. So these are the coordinate, based on the coordinate, these are the cluster centers. Now what we'll do, we will put cluster centers on this particular graph. So in the next line of code, what you will find, we are going to put this is scatter plot and the cluster centers both in the same line of cell of code, and we are going to do plt.show. So both plots will be getting in one particular plot, one graph, and here you can see. Now this X represents, because the marker that we have given is X. Okay. X represents the cluster center. So here is the cluster centers, cluster center for first cluster. Here is the cluster center for second cluster, and this is the cluster center for third cluster. Now, if you are going to see the distance of the clusters from these data points, it is uniform or near to uniform, because some data points are very sparse, right? Very sparse. This is how the clusters has been created. Clear till here, everyone? How K-means is working? Is it clear? Making sense till here? Yes, or give me a thumbs up. If any doubt you have, let me know. Clear. Okay, just a second. All right, perfect. Thanks for the response. Okay, one question we have got from Aditya. Sir, how do we use this plot for further analysis? for further analysis, let's say, as of now, we are not come to the conclusion, first of all. So we have just created the model with 3 clusters. We don't know how many clusters should be there. So we have to find out what should be the optimal number of clusters over here. So first of all, we are going to train the model again and again with different number of clusters, and we are going to calculate a lot of values. Let's see that type of things. Okay. So further analysis, you're not going to use this particular graph. Graph is not going to be used. The trained model that you have, it will get used. So what will ask the model to predict the label for the given data point. Now here lot of discussion of some functions are going to be happen. So few things we have. So we have some distance metric, and here we are going to talk about one more library called SciPy. SciPy stands for Scientific Python, a scientific computing package for Python. And you can just go to this document and you can learn a lot of things. Very useful library it is. So in SciPy we have a spatial.distance, and here we have cdist and pdist. We'll be using cdist and pdist over here. Why we'll be using it, we'll see. So first of all, let's import it, and this is the data point, so data set we have. Talking about cdist stands for compute distance. We use cdist to compute or calculate pairwise distance between two set of points in a space. In space means what? We're talking about the graph. 2 points in a space. So it can compute using various distance metric. By default, we use Euclidean distance only, but we have Manhattan distance, we have other cosine distance and more. So the result is going to be a distance metric where each element I and j, if I'm going to talk about metrics, we'll be talking about I and j, which represents the distance between the ith point from the first set and the jth point in the second set. For example, here I have just given this particular array, and you can find the Euclidean distance over here. Then we have pdist. Pdist stands for pairwise distance, and you will find pdist in both libraries called SciPy and NumPy both. And here, what difference it is going to have from pdist? So sorry, cdist. So pdist is going to calculate the pairwise distance between the points in a single set or a collection of points. So unlike cdist, it doesn't calculate the distance between two different set of points. We are talking about the single set. Within the single set, it will calculate. And again, same Euclidean distance we can use, other distance metric we can use, right? And the result is going to be typically a condensed distance metric, meaning it only stores the unique pairwise distances, excluding the self distance. Example I have added over here. You can look into the example. Now here comes the main part of the whole story. I told you that we need to train the model with different number of k's to understand what should be the optimal value of k. We are taking a range from 1 to 10. So actually it is going to have the value 1 to 9. What we are doing, we are creating a list of trained model. So this model we are going to train for I in k. Which k? This range. For each time, one value will be given over here. Let's say for 1 cluster, for 2 cluster, for 3 cluster, till 9 cluster. So total 9 trained model will be having in this list. It is going to be a list of 9 trained model. Then we are going to store the centroid of all these trained models in centroid. We will be calculating the cdist from the given data frame and the centroid. So cdist, here we have just talked about what is going to calculate. It is going to calculate the pairwise distance between two set of points in a space. Two set of points, what we have? We have df1 and we have the centroid. Equivalent distance. So we'll be calculating the cdist for all the centroids. So for cent in centroid, taking the DF1. And here we will be taking two things. We will be taking the ID, that is the index of the smallest distance in this particular DK list. So you will be having CDist, the calculated pairwise distance of these two sets. You are going to take the index of the lowest value element based on the axis 1. Axis 1 means what? The column wise, row wise. If you talk about the numpy, argmin is going to give you the value of the shortest distance, the index of the smallest value. Then we are going to take the minimum distance also, np dot mean. Here two things we are taking the index of the minimum distance, and we are also taking the minimum distance. Then we are going to calculate average within sum of a square. Average within sum of square means what? Sum of d that you are having here in this distance metric divided by the shape of the data frame, right? Here we will be within sum of the square. Now once we are done with all these things, what we need to do, we need to calculate few more things. WCSS, here it stands for within cluster sum of the square. So we are taking distance, sum of a square of the distance for all the distances. Then we are taking TSS, that is nothing but total sum of squares. So total sum of a square is nothing but the PDist of DF1 square, taking the sum of it and divided by the shape of the data. WSS, between cluster sum of a square. It is nothing but the difference between TSS and WCSS. It's very simple. Then we have variation explain. Variation explain is going to be BSS by TSS into 100. So all these things will get calculated, and how we are going to use it, let's see over here. Now we are going to plot something. What we will be plotting? So here what we are going to do, we are going to create a figure of let's say 10 by 4. We'll be having subplot, plot 1 and plot 2. Okay, two plots we'll be having. So one plot we are going to plot. So if I am going to simply use plot, that means line plot will be plotted. So we are going to make a plot with respect to k and average within sum of a square. And we will be adding the marker over there on the second index. So as of now, I know on the second index it will be there. So marker is optional if you want to give the marker, otherwise you can remove it. So we are taking all these things over here and we'll be plotting it together. Grid true, we want in the form of grid, giving the labels over here. And for the second plot, here we'll be having k with respect to variation explained. If we are going to see these two different plots, a lot of things will get clear. Now, as I told you, to find out the optimal value of k, we use elbow method. Now elbow method is going to be used to find out the optimal value of k, and how it is known as the elbow method. There is nothing called elbow basically, because the graph we used to create, it looks like elbow of a man. And if I'm going to take this thing, here we will be concentrating more on the variation explained. From where we are taking 3. Why we are taking 3? Because from 3 we can see this elbow is going to take a uniform move. Here you can see a sudden jump. Now from here it is going uniform. So from where it is getting uniform, that is going to be your optimal value of k. On 3 it is going uniform. So this is going to be optimal value of k. So you can take this variation explained, and based on the variation explained, we will be having the number of clusters. So as of now, we find out, okay, the number of clusters are going to be 3 only. So we can train the model again in the same way. And one more thing is there, the metric that we use to calculate how well our model is performing is going to be Silhouette score. So Silhouette score is simple. over here from scikit-learn, we are going to take the metric. We are going to import Silhouette score. Silhouette sample is not required. I've just added for your reference Silhouette score. So we need to train the model. Model will give some prediction, that is level, and Silhouette score needs these two things: df1 and df1, the data frame that you're using, the required column, and the y, the labels. So it is going to calculate some score. Silhouette score is not defined. Okay, I need to import it, guys. I need to import it. Yes, I'm going to run this now. Okay, Silhouette score that we have got is 0.56. 0.56. Last time I have taken it was 0.52. Based on that, I have written it over here. But so Silhouette score will be ranging from -1 to 1, -1 to +1. And if your Silhouette score is positive, that is a good sign. The first sign that you are having a good trained model, well-trained model, positive value greater than 0. The first good sign. If your Silhouette score is closer to 1, that is the second good sign. Second good sign. And good suppression. So basically this scores also mention that you are having very good suppression between the classes. So basically the Silhouette score that we have got over here, 0.56, it is a reasonably good score. It's suggesting that our clusters are well separated and well uniformed. All right, clear till here, everyone? Few part will be confusing. I know you have to go through this code again. A lot of calculation we have done over here, but this is not very big calculation, very small calculation we have done. Clear till here? Can I get a quick guess? All right, fine. So we can take a break right now. We'll be having a break of an hour. We'll be connecting on the same link at 1 o'clock. I hope you are informed that you are having one more session at 1 o'clock.